All right, so 1-4, AP Unit 1-4 is called Polynomial Functions and Rates of Change. It starts with like characteristics of polynomials. So these are all continuous graphs. These are your graphs that look like a roller coaster. Goes up and comes back down, goes up and comes back down, that kind of a thing, okay? Poly means many or much, okay? Non-constant polynomial function is a function with many terms in the form of, and this big, long, obnoxious thing just means that there could be all these variables. So x could be variables, right? And the way that they are put in order is decreasing degree order. So if I have x to the fifth, then it would be x to the fourth, then x to the third, then x to the second, then x to the first, then x to the 0, which would really be your constant, okay? Those are your, so the highest one is the degree. We put them in order of highest to lowest. And then the number on the front of them are your coefficients, okay? The last one's a constant because it's by itself, but everything else is a coefficient. And the number on the front of the highest exponent is called the leading coefficient. So you're going to see some like vocabulary terms in this section. It says where n is a positive integer and a sub 1 is a real number for each one from 1 to n. Sorry. Again, it just means exponents are all going to be positive integers. There's no negative exponents in a polynomial. And it means all the numbers on the front of them are real numbers. There's no i's or complex numbers. Okay, we're going to get to those, but not yet. All right, so these are smooth and continuous. There are no starts and stops. These in the bottom right corner are not polynomials. So piecewise functions are not polynomials. Anything with a sharp corner, not a polynomial. The polynomials are going to be smooth and continuous. Okay, they can go up, down as many times as it wants. But they are all one fluid. They are still functions, which means they would pass your vertical line test. And the graphs of polynomial functions can have at most n minus 1 points, n being the highest exponent. N minus 1 turning points. So if my highest exponent is 5, then the most amount of turning points it can have is 4. If my highest exponent is 3, the most amount of turning points it could have is 2. Now it does say most because it can have less than that. Because something with an x to the third might have one real 0, but then it might have 2 imaginary zeros, and so you would only get 1 turn. So if you look at the graph, let's say I look at this one on the left. Turn point is every time it goes from increasing to decreasing. So this is one turning point, then decreasing to increasing. This is a second turning point. So if I counted all my relative max and min, those would be your turning points. All right, example 1 says, what's the leading term, what's the degree of the polynomial, and what's the leading coefficient? So we're going to put it in order of decreasing degree first, which means the 7th power comes first. Negative 3x to the 7th plus 2x to the 3rd would come next, plus 5x squared would come next, plus 1. Now the leading term is the whole term. So positive, negative sign, value, and exponent, which means that 3x, or negative 3x to the 7th, is my leading term. What would be the degree of it? 7 is the degree of the polynomial, so highest exponent is your degree. And what's the coefficient, or the leading coefficient? Negative 3. So right now we're just identifying those parts, but eventually we're going to learn that those things mean stuff to the shape of my graph. So it could have 6 or 4 or 2 or 0, depending on how many non-real numbers there are, is what fills in that space.
The minus 1.
What? Right, the n minus 1. Yep. So it would have 6, a max of 6 turning points. All right, now let's talk local or relative extrema. So we talked about it last week. When we're talking about extrema, we're talking about maximum and minimum values. There's either local or absolute. Local is the same as relative. So a local max occurs anytime the graph changes from increasing to decreasing. A local min occurs every time the graph changes from decreasing to increasing. You can have multiple local or relative extrema. And an included endpoint of a polynomial with a restricted domain may also have local or relative extrema. And I'll show you what that looks like. So if I have a graph drawn, and it looks like this, for example. Every time it changes from increasing to decreasing, there's a local max. So this is a local max, this is a local max, this is a local max. And every time it dips from decreasing to increasing, there's a local min, local min. So there are 5 total extrema here. 3 local max, 2 local min. But what can also happen is on the left there, it's a solid point. It doesn't go down and come back up again. But if my domain is restricted to that point, so if it said on the interval of, I don't know, let's say this is -2, from -2 to infinity, as soon as I restricted the left side of that graph and it cut it off, that is considered a local minimum. So even though it's not absolute, it's not the lowest one, okay? There's a lower point than the absolute minimum, okay? If my domain restricts my graph and stops it at a point, it could count as a local min or a local max, depending on if it's high or low. All right, global is the same thing as absolute, and there is only one. You can only have one global max, and you can only have one global min. The global or absolute min is the lowest point on the whole graph, and the absolute global max is the highest point on the whole graph. Usually the format of this answer is y equals a point. I mean, like y equals the y coordinate of the point. So on a relative max or min, we would give it in coordinate point form because it's going to happen multiple times. So you're going to give the x and the y, the x and the y, the x and the y. Whereas if it's global, so if my graph looks like this, for example, this is the highest point on that graph. And so if this was 1, 2, 3, 4, 5, let's say that's 5, my global max is y equals 5.
So the x is,
sorry, again?
the x point, the x.
You give,
The x.
oh, no, sorry. Y equal, no, I gave, this would be 1, 2, 3, 4. Sorry, thank you. Y equals 4 would be your max, okay? Where it happens, it could say, what's the value of x when it hits its max? That value would be 5. But when you give the actual answer to that max or the min, you would give the y coordinate of it. There is no global min on this graph, right? Because those arrows point down. So even if just one arrow points down, it means it's never going to stop. There would be no absolute or global min. All right, example 2 says use the diagram to answer the questions. A, find the absolute min of blank. That means that's your y when x equals blank. The absolute max of blank, what's the y when x equals? The relative minimums occur at what x value, and the relative maximums occur at what x value. See if you could do it. All right, so what's true about what does the arrow pointing down tell you about this graph? It means it's never going to stop going down. So when it asks for an absolute min, you would say what? There's none. So you can either say D and E, you could say none. It will usually say, if there's none, state this. And you just want to pay attention to that, okay? Doesn't exist. How about the absolute max? Is there a highest point? Yes, it is here, right? So the absolute max is what? 7 when x is 0. Good. Are there relative minimums? Yes. Where? -3, 3, right? It comes down and it goes back up again. That x value is -3. If it said, what's the relative min, we'd give it in coordinate point form. If it says, what's the x at the relative min, we give the x. If it was the y at the relative min, we get the y, okay? If it doesn't explicitly say it, then I would write -3, 3 like that, okay? But this time it's explicitly said it occurred, like where is the negative, or where's the relative min occurring where your x equals, that's what you want to give the x. All right, how about relative max? How many are there? There's 2. This one is cut off by the edge of your graph. So although it went up and didn't come back down again, that is still a relative a relative max, sorry. And then this is my other relative max. So the one occurs at -6 and the other occurs at 0. No. You have to give a specific location for relative min and max or absolute min and max. You can't ever put infinity.
Source above you put infinity for something, so I thought we did.
What did we put infinity for?
Oh, sorry.
It's okay. Yeah.
Wait, so even though it's not like a curve.
Right, even though it doesn't go up and come back down again, because it went up and stopped, we treat it as a relative, just relative, because this one's still higher, so that's your absolute.
And then it just went down and stopped. Would also be
It would be a relative min. Yep. Yeah.
But since there's an arrow, that's why it's not a relative minimum.
That's why it's not an absolute. Oh, this one? Yeah, no, you can't name this.
Yeah, but
There's no way.
But if it was like a...
If it was a dot, I'd include it. Yep. Good questions.
If it was a dot, you would put it as a min.
Relative min. Yep. Good? Okay. All right, so extrema between zeros. And like the AP style questions, the multiple choice questions, like what could the behavior be on this part of your graph? And it's going to be based on zeros and that kind of stuff. And part of it will ask, can there be a relative min extrema? Does there have to be one? That kind of a thing. And the rule is if you have 2 zeros on a non-constant, so we're not talking about a horizontal line, 2 zeros of a non-constant polynomial, then there must be at least one extrema between them. So if I tell you that there is a 0 at 1 and at 4, think about all the things that could be happening in between here. I could literally just go up and come back down again, and that would be a relative or an absolute max, right? I could go down and come back up again. I still have a relative min or an absolute min. I could go up, come back down, come back up, come back down again. And I still have to have at least one, right? I could have more than one, but I have to have at least one in between those 2 points. You could even bounce off of one, cross through the other. There's still one there. And I could bounce off of both. And there's still one there. So it has to be at least one between any 2 points. At this point, we're going to learn. Remember, we talked about last year, like bouncing and crossing through. Either way, there will be some sort of relative max or min between the 2 points. Yep.
Will this be absolute max or like a?
It's relative. Correct. So it's talking about local, and local means relative. Yeah.
Could your local and absolute be the same?
Yes.
If it's like only one.
Correct. Yep, if you only have one local max, because your arrows are pointing down, it is both the local and the absolute.
So would we, if we were asked like absolute max and then local max,
You would give it for
the same
both.
thing
Mhm.
for both?
Yep.
So absolute is just the biggest one.
Absolute, there's nothing above it along the whole thing. Yep. Yeah, sure. Yeah.
Will we ever deal with a straight line?
Like, are there constants in the world of functions? Yes, but not in polynomials. They're always bouncing because it has to be smooth and continuous. Yep. Yeah.
What's the difference between like relative maximum and like absolute maximum?
There can only be one absolute maximum because no other point can be higher than it. an absolute, a local or relative, those mean the same things. It could go up and come back down and go up and come back down and go up and come back down, and all three of those count as relative max. But if one goes up and one goes higher and then comes higher, there's only one absolute.
So,
So there's either one or no absolute, and there's multiple
and the
local.
the absolute one is gonna be a part of the local ones?
Yeah. Yeah. Not necessarily the other way around, but yes, yeah. All right, example 3 says let f of x be a polynomial function with the given values. Are there any guaranteed extrema? If so, state where they occur. All right, so this is where they take something that is actually quite easy and they make it complicated because they put it in function notation. Each of these is literally just a coordinate point, right? Because f of 0 equals -1. The inside is the x. What it's equal to is the y. So this is 0, -1. F of 1 equals 0 is the coordinate point 1, 0. And f of -3, 0 is -3, 0. You with me so far? So you don't have to do this, but if you needed to visualize it, 0, -1 is down here. 1, 0 is here. -3, 0 is here. How many of these are zeros? 2. Which ones? The 1, 0 and the -3, 0, because your y is 0, right? When the y is 0, that is a 0, okay? So, are there any guaranteed extrema?
Yes.
Yes. Where is it?
Between the 1 and -3.
Good. Yes. Between -3 and +1. It was pretty loose in how it asked it. It didn't say interval notation. It didn't say something like that. If it had asked for interval notation, it would have been between -3 and 1. Okay, with actually could be parentheses on there. Yeah.
What's extreme?
A max or a min. So it has to happen because it could come down, come back up again, come down, come back up again. We don't know what's happening in between here. But there are 2 zeros, and between every pair of zeros, there has to be at least one local extrema. So all you're looking for is, are they zeros? I don't even care what happens in between. All right, even degree and absolute extrema. If the polynomial has an even degree, okay, there is either an absolute max or an absolute min. Think about why this is happening. If it has an even degree, and this, we'll get to end behavior, I don't know why, but it waits till 1-6 to talk about end behavior. But if you remember from Algebra 2 honors, if it's an even power, then they either both point up or they both point down. So think of a parabola, right? X to the second, both point up, both point down. X to the fourth, the same thing would happen. Both point up or both point down. As you add in x values between the x to the fourth and the constant, it will go up and come back down and go up and come back down maybe. But at the ends of your graph, they will either always both point up or both point down. Which means there has to be an absolute max or min because it's got to stop and come back up again, or it's got to stop and come back down again. Yeah.
So the other one will be none. One will have a value and the other one will be none.
Correct. Wait, what do you mean?
Either the absolute.
It's
max
either going to have a max or a min. Correct. Yes. So if it's a positive leading coefficient, if it's a positive number on the x and an even power, then both my arrows point up. And if that happens, I have an absolute min. Because it's got to go something like this. It could go up on the left and up on the right, and then it could squiggle in between, but both ends are going up. If it's got a negative leading coefficient, so it's negative x with an even power, now they are both pointing down at the ends. So down and down. And again, it could go up once. It could go up and back down again and up and back down again. It could do that 5 times, okay? All I know is they both end up pointing down, which means there has to be an absolute max point. So even, positive, both are up, has to have a max. Even, negative, both point down. Did I just say max? Yeah. Even, positive, both point up, it has to have a min. Even, negative, both point down, it has to have a max.
So when you do the positive, you have an absolute min, but you can't have an absolute max.
Correct. Correct.
Okay.
Yep.
Is the leading coefficient the coefficient attached to the highest degree?
Correct.
The one with the highest degree?
Correct. So all of this, because we're talking about degrees, right? Even degree, that means highest exponent. You look at the one with the highest exponent, you look at the number on the front. Even, both up, or both down, depending on if that number on the front is positive or
One
negative.
says -7 exponent and one says -5. -5 is greater. Okay.
They won't have negative. It won't be. That's not a polynomial. That's a reciprocal function. It won't be in here. Yeah. All right. Example 4. Is there an absolute max or min for each function? For A. Good. Yes. The answer is yes, and it is a min. B. Trick question. We don't know. We don't know. Okay? So because it's well, actually we do know it's a no. Not just we don't know. Because we know it's a no. We didn't talk about it. But an odd power means one's got to go up and one's got to go down. There's never a min and there's never a max. Absolute. Okay? Odd, they switch like a cubic function. How about C? There's an absolute max. Yeah. Because a cube looks like this. One goes up, one goes down. But absolute. It's got to be absolute. It could be relative. It could come up and come back down and come up and come back down and then go up. But it's always going to go up and it's always going to go down. Correct. So even they're going one direction. Odd, they're going different directions. Yeah. It doesn't matter. We're looking at the highest exponent. Highest. Yep. Yeah.
What determines
All right, last thing we're going to look at is point of inflection. And we talked about it the other day because I don't know why it holds information and waits for it. But are we good on the last one? Everybody's good? Okay. Point of inflection is every time your curve changes, the rate of change of your curve changes from increasing to decreasing. What do we call that? The rate of change increasing is concave up. Rate of change decreasing is concave down. So when our graph changes from concave up to concave down, from our U's to our N's, it's called a point of inflection. So if my graph looks something like this, then I can have this part concave down, this part concave up, and I would have exactly one point of inflection. So the point of inflection is where your graph changes from concave up to concave down or concave down to concave up, okay? There can be multiple, especially when we get to polynomials with lots of turning points. There's going to be multiple inflection points. Questions on that? All right, example 5. Identify the point or points of inflection. Where do we think it's happening? 2.33, 8.29.
What class did you teach?
Concave down, concave up.
I'm going on 10.
Yeah, you are.
I'm seeing names there. Do all those kids, are all those kids named? Oh,
No.
Yeah, they're last year.
Questions? Easy stuff, right? That's just like if you know a vocab term, you got it.